Chapter 4, Congruent Triangles, Section 2, Triangle Congruence by Side, 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 and Side, Angle, Side. So the first postulate here is postulate 4.1, SSS postulate, which is the side, side, side postulate. If three sides of one triangle are congruent to the corresponding three sides of another triangle, then the two triangles are congruent. So just given this example, we have triangle ABC and triangle ACD. They're telling us that AB is congruent to AD and that BC is congruent to DC. We want to prove that the two triangles are congruent, and one method of doing that is to prove that the three sides are congruent to each other. Well, looking at this diagram, the triangles share a common side. Now this is where the reflexive property is useful. We can say that AC is congruent to itself, and now we know that all three corresponding sides, so meaning here we have the shorter leg and the shorter leg, the longer leg and the longer leg, and the third side are all congruent to each other. We can then state that the triangles are congruent to each other. So our first step would just be to state the givens. And then we could use the reflexive property of congruency to show that AC is congruent to itself. Make sure you're including that it's the reflexive property of congruency. Now we have two sides congruent, the third side congruent. We can skip right away to telling that the two triangles are congruent. And this would be because the three sides are congruent to each other. And just to sum it up, if three sides of one triangle are congruent to three corresponding sides of another triangle, the two triangles are congruent. That would be the end of our proof. Now the second postulate from this section is side, angle, side. If two sides and the included angle, so you have the two sides and the angle in between them, are congruent to the corresponding two sides and included angle of another triangle, then the two triangles are congruent. So we have our given that line segment PM bisects angle LMN, and LM is congruent to MN. So we want to prove that the two triangles are congruent. Now we can see that this is one big triangle here, but we can also see that MP is the angle bisector of LMN. So we're really looking at LMP and PMN, especially because that's what we're trying to prove are congruent. We're going to mark off what we know. LM and MN are congruent to each other. And we also know that if PM bisects LMN, bisecting an angle means it cuts it into two congruent parts. So we also know that those two angles are congruent, but we do have to state that because we're getting it from part of a given, but we're kind of coming up with a new conclusion. Now, side, angle, well, again, using the reflexive property here, we would have that third side, and then we can prove by side, angle, side. So first we're going to state the given, that line segment PM bisects angle LMN, and that line segment LM is congruent to line segment MN, and that's all because it was given to us. Now our second statement would have to be something about the angles being congruent. So we know that angle LMP is congruent to angle PMN because an angle bisector cuts an angle into two congruent parts. So that now gives us our angle. So now we have side, angle, and using the reflexive property, we can say that MP is congruent to itself, and this is by the reflexive property of congruency. And now we have side, angle, side. So we can state that the triangles are congruent to one another because side, angle, side is congruent to side, angle, side, meaning if two sides and the included angle are congruent to the corresponding two sides and included angle of another triangle, the two triangles are congruent. And that would be the end of our proof there. Finally, given this picture, how would you prove triangle ABC is congruent to triangle DEF? Using the two postulates that we just found out about, which one or which ones, you could use both, would be best to prove that these two triangles are congruent? Well, we can see that corresponding side AB and FE are congruent. BC and DE, those are our corresponding sides, are congruent. And AC and DF are congruent. So we could say that triangle ABC is congruent to triangle DEF because three sides are congruent to the corresponding three sides. So that's one way that we can prove them congruent. Now, notice that from this picture to this picture, not only did we have a translation, but we also had a reflection because this is now on the other side. But the other postulate that we used was side, angle, side. And the rule for side, angle, side, that it was the included angle between the two congruent sides. So in ABC, we see that it's in between AB and BC. It's in between the 1 marked and the 3 marked. Well, in between the 1 marked and the 3 marked, the corresponding angle to ABC would be this angle, DEF. And we don't know anything about DEF. Right now, it's telling us that angle EDF is congruent to angle ABC. But EDF is actually corresponding to this angle. So we cannot use side, angle, side here because it's a different angle. They're not corresponding angles. We would be able to prove them congruent by side, 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 which means that these angles would wind up all being the same measure. But we can't use it to prove that the triangles are congruent because they didn't tell us anything about the corresponding angle. We're not using the included angle, we're using a different angle, so you can't use side, angle, side.